So, guys, today we are going to discuss a very interesting and a very hard OA problem which was asked in Intuit some days ago. Okay, so this is the problem. Okay, first let's read the problem, but before that, guys, let's jump straight to the problem. So, guys, the thing is that nowhere in any DSA course or any LinkedIn or YouTube influencers DSA videos, you are going to see that people are trying to explain you hard level interesting OA solutions, which are based on hard DSA concepts and lots of observations and analysis and thinking skills. What people generally teach, they only teach you the easy, popular interview problems of GFG lead code. No one trains you for hard, unseen problems which are asked in OA. If you are not able to crack OA, how will you reach the interview? It doesn't make sense, right? So I have seen a very big market gap that no one is trying to help the students for OA. So I have taken the responsibility to make sure all the students are able to pass their OA with the best flying colors. Okay, so we are not going to discuss this problem like other normal people. We are not just going to read the question and come to the answer. What we will do is we will read the question, we will reach some analysis, some conclusion, some understanding. From those conclusions and understanding, our solution is going to come naturally and organically. We are not going to do anything unnatural or unintuitive. Okay, so let's start. What is our problem? So the problem is playing with zeros and ones. Alice is playing with numbers zeros and ones. She decided to count the number of subarrays which satisfy the following condition. Ratio of number of zeros to number of ones is x is to y. She starts struggling as soon as the count of numbers increase. Can you help her find the solution to this problem? Constraints are n goes from 1 to 10 raised to 5, x goes from 1 to 10 raised to 5, y also goes from 1 to 10 raised to 5. This is such a brilliant, interesting problem. I'm surely going to add this to my course. If a guy or a girl or anyone does this problem, their concepts for hashing for any OA will be super strong, be it Google OA, Amazon OA, or Microsoft OA. This problem is like so much important for people who are trying to improve their DSA thinking skills in the hashing topic. So, what is the question telling us? Question is saying, okay, my introduction, I'm founder at Desi Q&A, also software development engineer at Amazon, and previously I was very much involved in competitive programming, and till today I'm very much interested about DSA and problem solving, and in the past I had world rank 368 in Google Kickstart. So what is the question telling us? Question is saying that you are given an arrays of zeros and ones. Find the number of subarrays which have this property. Guys, we have to find the number of subarrays such that the number of zeros in that subarray, number of zeros in subarray or number of zeros in that subarray divided by number of ones in that subarray should be equal to x by y. So you will be given the size of the array, you will be given an array which will only have zeros and ones, and you will be given x by y. You have to output the total number of subarrays such that the number of zeros divided by number of ones is x by y in that subarray. So let's take this example: 1 0 1 1 1 1 1 1 0 1 1 1 1 2 3 4 1 2 3 4 5 6 1. So guys, now we have to find the subarrays such that the number of zeros divided by the number of ones x by y should be equal to 1 by 2. It's very easy and it's really interesting. Okay, so what can we do? This is a valid subarray, guys. Can you see? 0 1 1 is a valid subarray. Why is it a valid subarray? Why is it a valid subarray? Not hard, very easy. The, in this case, x is what? Number of 0 is 1. X is 1. And what is y? Y is 2, there are two ones. So the ratio is coming correct. So this is a valid subarray. How many valid? One valid subarray we have found. Now let's go to the second valid subarray. 101 is also a valid subarray. 101. In this case, how many zeros are there? X by Y. X is nothing but the number of zeros. How many zeros are there? One zero. How many ones are there? Two ones. So 1 by 2. So this is a valid subarray. This is a valid subarray. So in total, there are two valid subarrays. Okay, guys, two valid subarrays. In total, there are two valid subarrays. So the thing is that there are two valid subarrays. Similarly, we wrote in our case also that for n equal to 7, this is our array and x by y is 1 by 2. This is one valid subarray. Okay, x is 1, y is 2. And this is one valid subarray. So how many valid subarrays are there? Two valid subarrays there are there. This and this. So answer is 2. Let's go to the next case. N is 7 and this is the array. So life is so interesting, guys. 1, 2, 3, 4, 5, 6. 100 1 2 3 4 100 1 2 3 4 100 1 2 3 4. Again, we want x by y equal to 1 by 2. See, this is our requirement. X by y equal to 1 by 2. So, how many valid subarrays are there? First valid subarray is from 3 to 5. Let's check. What is 3 to 5? This is index 1. This is index 2. This is 3. This is 4. This is 5. This is 6. And this is 7. Okay. So, guys, the thing is that now we need to really focus. What is happening from 3 to 5? 3 to 5 looks like this: 0, 1, 1. So, here, what will be x by y? Number of 0 is 1 and number of y is 2. So, we wanted 1 by 2 only. We are correct. So, one valid subarray we found, guys. Now, which is the another valid subarray? 1 to 6 and 2 by 7. 1 to 6 and 2 to 7. So, 1 to 6 is this subarray. This is a valid subarray. So, let's write it out. 1, 2 times 0, then 1, 1, 1. In this case, guys, what will be the value of x by y? So let's try to figure it out. There are two zeros, so 2. How many ones are there? 1, 2, 3, 4. So 2 by 4. We want x by y is 1 by 2. So 2 by 4, if you reduce 2 ones are 2, 2 twos are 4. This is 1 by 2. Okay, guys? So yeah, this is also a valid subarray. And which is the third valid subarray? It is 2 to 7. It is 2 to 7. So it looks like this: 0, 0. This is index 2. This is index 3. 2 to 7 is also a valid subarray. Why? X by y you try to do. You will find out that x, the number of zeros are 2, the number of ones are 4. 2 ones are 2, 2 twos are 4. So the answer is coming out as 1 by 2. That's it, guys. That's it. So 1 by 2. So yeah, three valid subarrays are there: 3 to 5, 1 to 6, 2 to 7, and hence the answer is 3. So guys, now what will be the brute force solution to this? It's very easy to imagine. All you have to do is consider all the subarrays and check if those subarrays are valid or not. If the subarray is valid, you increase the counter. If it is not valid, you don't increase the counter. As simple as it could get. So guys, what do? It's very easy. Okay, say you are given a array like this, right? You are given an array like this, right? 1, 2, 3, 4, 4, 5, 6, 7, 8. Let's destroy this. So what can you do, guys? First, you can calculate the number of zeros and ones, all the number of zeros and ones for all the subarrays starting at index 1. So you can calculate the answer for this subarray. You can know the number of zeros and ones here. Then you can calculate the answer for this subarray 1 to 2. Then you can calculate the answer for this subarray from 1 to 3. Then you can calculate the answer for this subarray, which is 1 to 4. Then you can calculate the answer for this subarray 1 to 5. Then 1 to 6. Then 1 to 7. Then 1 to 8. Once this is done, you can start from the index number 2. You can calculate the answer for subarray starting and ending at index 2, this part. Then 2 to 3. Then 2 to 4, 2 to 5, 2 to 6, 2 to 7, 2 to 8. Then 3 to 3, 3 to 4, 3 to 5, 3 to 6, 3 to 7, 3 to 8. So basically, I equal to 1. Now consider all the subarrays starting at index 1. 1 to 1, 1 to 2, 1 to 3, 1 to 4, 1 to till from 1 till n. Okay. Now coming to the next part, what we can do is that now what can we do? We consider all the subarrays starting at index 1 from 1 to 1, 1 to 2, 1 to 3, 1 to 4 till 1 to n. Similarly, like the 1, the starting number will be our I pointer, and the other numbers which are increasing, they will be our j pointer. Okay, so j will be going from I to n. Basically, it's very common sense. First, I am trying to consider all the subarrays which start at index 1. So my I is 1 and j is going from I to n. So like that, basically, again, if I say this was your subarray, right? And this was your index 1, right? So first I am considering only this much part, then I am considering this much part, then I am considering this much part. And whenever you are considering a part one size bigger, you only need to know if there was a 0 or 1 here. You can add that count and then you can easily know. Okay, like this, like this, like this, like this. Okay, so similarly, you for once you have considered all the subarrays starting at index 1, then you can start considering all the subarrays starting at index 2, from 2 to 2, 2 to 3, from 2 till n. You can do till for I equal to 3, you can do this till I equal to n. All the subarrays starting at index n is, there is only one such subarray, which is n to n. Okay, so guys, now once you say catch a subarray, how will you know if say guys, this is a subarray? Okay, just assume this is a part of some array. Starts at index I, ends at index j. Say you calculate the number of ones. The number of ones in the subarray, let's call it as 1. The number of zeros of this subarray, let's call it as 0. So how will you know if it is valid or not? If 1 by 0, if 1 by 0 is equal to x by y, it means it is a valid subarray. Simple. If for this subarray you know the number of ones are 1 and the number of, sorry, 0 comes above. If the number of 0, if the number of 0, I am calling it as z, okay, if the number of 0 divided by the number of ones, I am calling it as one, 1. If 0 by 1 is x by y, it means it is a valid subarray. For example, how to know if a subarray, subarray is nothing but a part of an array. If a subarray, how to know guys if a subarray starting at index I and ending at index j is valid? Say 0 is equal to number of zeros in that subarray, and 1 equal to number of ones in that subarray. Okay. Hence, if if 0 by 1 is equal to x into x by y, or you can do the cross multiplication, or okay, now this is you if it, this is not good way to check, this is not good way to check, as decimal point can come into the picture, decimal points can come into the picture. Okay guys, this is not a good way to check, as decimal points can come into the picture. So you can do cross multiplication. So 0 by 1 should be equal to x by y. So if you do the cross multiplication, z into y, 0 into y should be equal to x into number of ones. Okay, 0 into y, 0 into y, it means if 0 into y is equal to x into is equal to x into 1, this means subarray is valid. How valid? How we know that? This is a good way to check. This is a good way to check because LHS and RHS, the left hand side of the equation and right hand side of the equation, both will remain integers only. Will be integers only and easy for the program to check. You could do this also, but this is having this division operator, na? So if you divide two numbers, it can give something like 3.53535353, and this can also give 3.53535353 infinite. So the compiler might do some mistakes. So we don't want to go into that mistakes. That's why. So that's it. Now how will we run our code and our algorithm? Let's go to the algorithm. It's very easy. The time complexity, obviously, we are checking all the subarrays, so it will be O of n into n, two nested for loop. No extra space is used apart from the array B, but we assume that array B is already given to us in the question, so we don't add space for it. So it's constant space complexity is O of 1. Time will be O of n square. See, if we go to the pseudo code and the pseudo algorithm, what will happen is that you guys can see that n, the size of the array b of n plus 1, we take an array b of size n plus 1. Then from 1 till n we read all the integers of array b. Okay, we read x, we read y, I equal to 1, count equal to 0. So I is our starting pointer, right? I is going less than equal to n. So now we need to consider all the subarrays starting at index I. And for example, as I said previously, first, we will be considering all the subarrays starting at index 1. So I is equal to 1. I is equal to 1, and j will be initially be 1, but j will keep on increasing. So first we will consider from I to j. So it will be 1 to 1, then it will be 1 to 2, then it will be 1 to 3. Till that we will go forward. So basically what we do is going to that code. Where did we go? Yeah, I initialize a 1 counter and 0 counter, which will be counting the number of ones and zeros in that subarray. I is the starting pointer of the subarray, j is the end pointer of the subarray. So initially I only consider subarray of size 1. So I is 1 and j is also 1. So 1 comma 1, the first subarray. While j less than equal to n, obviously first I will consider 1 comma 1, then 1 comma 2 till 1 comma n. So if the number is 0, I increment the 0 counter. If the number is 1, I increment the 1 counter. And then I write the same condition. If 0 into y, guys, if this is equal to 1 into x, see I wrote here. If 0 into y equal to 1 into x, then I increment the counter. This is the valid subarray. The j incrementing, I incrementing, that's it, and I print the count and our job is done. You can analyze this code in detail later on. It's very easy. Now, let's come to the efficient solution. Let's try to think about it. Guys, before going to the efficient solution, we will be needing this prefix arrays. Okay. Now, if you are my pro batch student, you must be knowing the basics of hashing. You might have watched the super rich courses on hashing, the first two video sessions I had, right? So, in that, the prefix sum method was explained in detail. I am saying that let's make some prefix arrays. Okay, it will be used later on. Prefix 1, okay, first I will make a prefix 1 array, then I will make a prefix 0 array. What is a prefix 1 array? Prefix 1 array is an array which will be counting the number of ones from index 1 to I of the array. Okay, guys, prefix 1 array will be the array which will be counting the number of ones from index 1 to index I. Prefix 0 of array will be the number of zeros from index 1 to I of the array. Okay, so basically, if I give you ones and zeros, how will you calculate the prefix 1 and 0 array? For example, this is our array B. Okay, it looks like this. Okay, first there is this 1, then there is this 0, then there is this 1, then there is this 0, then there is this 0, or say 1. So prefix 1 array, let's call it as P1. It should count the number of ones in the array B. Okay, so how many ones are there? How many ones are there till index 1? There is only one 1. So there is 1 1. How many ones are there in the first two indices? Only 1. So answer will be 1. How many ones are there in the first three indices of array B? There are 2 ones. So answer will be 2. How many ones are there in the first four indices? 2. So answer will be 2. How many ones are there in the full array? 3. So answer will be 3. This is our prefix 1 array which counts the number of ones till index I. Similarly, if you try to make P0 array, okay, how many zeros are there till one index? There is no zero, so answer will be 0. How many zeros are there, guys, in the first two indices? There is only one zero, so answer will be 1. How many zeros are there in the first three indices? There is only one zero, so answer will be 1. How many zeros are there in the first four indices? There are only two zeros, so answer will be 2. How many zeros are there in the full array? Only two zeros, so answer will be 2. So guys, this is called as prefix 1 array, this is called as prefix 0 array. That is the same thing I have written, the prefix 1, prefix 0 array. Prefix 1 of I will tell you the count of ones from index 1 to index I of the array B, and prefix 0 of I will tell you the count of zeros from index 1 to index I of the array B. Clear, guys? Now say if you are considering a subarray from index I to j, then how will you know the number of ones in that particular subarray from I to j? And how will you know the number of zeros in that particular subarray from I to j? This is the most important part. Okay. So guys, the thing is that now what do we need to do? We just need to chill out in this life. The life is very good. Good. God gave us the best possible life. Ram. So guys, how will you know the number? You always know the number of ones from 1 to I. Okay. They are saying array is starting at index 1. Okay. Say array is starting at index 1. In somewhere in the middle there is a index I. And this is index n. So how many ones are there from 1 to I? Prefix 1 of I will give you the number of ones. Count of ones from 1 to I. So in this part of the array, how many ones are there? It can be easily be said by the prefix 1 of I. Okay, it is stored in this particular index of this array. So pref 1 of I can tell you the number of ones from 1 to I. But the question is, if someone gives you say index I and then gives you some index j, they are telling you how will you know the number of ones from index I to index j. So this is also common sense. Wo- Say this is index j. Okay, You want to know the number of zeros from index number of ones from index I to index j. So what you can do, guys, it will be nothing but what? It will be p of j minus p of I minus 1. So basically the solution is nothing but the number of ones from 1 to j minus the number of ones from 1 to I minus 1. If you subtract this much part from this much part, this will be left. Basically, say you are at this index, okay, this is the index I, and some guy is coming and telling you, this is say index n. Guy is coming and telling you, tell me the number of ones which are there from I to j. So what you can do, you can calculate the number of ones from I to j is nothing but what, guys? The number of ones from I to j is nothing but the number of ones from 1 to j. First you calculate the number of ones from 1 to j. This is very easy. You calculate this and then subtract the number of ones from 1 to I minus 1, then only this much part will be left. Got it, guys? Can you visualize? Yeah. So the number of ones from 1 to j minus the number of ones from 1 to I minus 1. Okay, guys. So number of ones from 1 to j, number of ones from 1 to j. So how many ones are there? How many ones are there from I to j? It is nothing but number of ones from 1 to j minus number of ones from 1 to I minus 1. Okay, guys. So how many ones are there from I to j? It is simple. Number of ones from 1 to j minus number of ones from 1 to I minus 1. If you subtract these entities, you'll get the answer. So what is the number of ones from 1 to j? It is prefix 1 of j. Minus what is the number of ones from 1 to I minus 1? It is prefix 1 of I minus 1. Same property will be followed for zeros. How many zeros are there from I to j? Prefix 0 of j minus prefix 0 of I minus 1. That's it. For now, let's substitute these values in our equation. So guys, for a given subarray, for a given subarray, guys, suppose we are considering a subarray from I to j. Okay, we are considering a subarray from I to j. Okay, we are considering the subarray from I to j. So guys, what is the equation for this to be valid? The number of zeros divided by number of 1 should be equal to x by y. What will be the number of zeros? Number of zeros will be this: pref 0 j minus pref o pref 0 I minus 1. So pref 0 j minus pref 0 I minus 1 divided by number of ones. What will be the ones from I to j? Pref 1 j minus pref 1 I minus 1. So this divided by this should be equal to x by y. Let's rearrange the equation. We will get pref 0 j minus pref 0 I minus 1 into y equal to x into pref 1 j minus pref 1 I minus 1. Let's rearrange the equation. We will get something like this. So guys, pref 0 j into y minus x into pref 1 j is equal to pref 0 I minus 1 into y minus pref 1 I minus 1 into x. Okay guys, if this condition is equal, if this left hand side term is equal to the right hand side term, it means this is a valid subarray. Now using this condition, you can very quickly calculate your answer. Okay, for example, Let's say you are at some particular index j. Okay, you are at a particular index j. Okay, say there is an index, its name is I5. Its name is I5. There is some index, its name is I8. So how can you know all the valid subarrays ending at index j, guys? Ending at index j. Let's assume there are two valid subarrays ending at index j. There is this one subarray from I8 to j, and then there is one valid subarray from I5 to j. Okay, one is from I8 to j, another is I5 to j. Okay, guys. Now, so for this, LHS should be equal to RHS. LHS should be equal to RHS. If this is a valid subarray from I8 to J, it basically means the value which we calculate here should be equal to the value which we calculate here. So yeah, let's use a eraser for now. LHS should be equal to RHS. So basically, what is the RHS? Okay, let me write this stuff there. Guys, that is the LHS, this is the RHS, okay? So this is the RHS, the jth index term, and this is the LHS. These both quantities should be equal, okay na? So what is the RHS? RHS is very easy. You only need to calculate pref 0 j, which has already been calculated. We will make the pref 0 and pref 1 arrays before the main algorithm starts, so you don't need to calculate, you know the value. So if you calculate pref 0 j into y minus x into pref 1 j, this will only take O of one time, because you already know the value of pref 0 j. Y is already given in the question, x is already given in the question, pref 1 j is already given in the question. So RHS, you calculate, its name is RHS. Okay, so all you have to do, you calculate the RHS. Okay, I calculate the RHS. Now you calculate the LHS for this. Okay, what is the LHS? For I8, it will be pref 0, I will replace by I8. I8 minus 1 into y minus pref 1 into I8 minus 1 into x. So this will be the LHS. This will be the LHS. So let this LHS be L1. Let this LHS be L2. So if L1 is matching the RHS, it means this is also valid subarray. If L2 is equal to RHS, it means this is also valid subarray. So basically, for each index j, we are trying to find the valid subarrays which are ending at index j. Okay, which are ending at index j. You don't even need to look these things. I will explain in a very easier manner. LHS should be equal to RHS, guys. Okay, so our equations are same. See, on both the sides, LHS is also similar. See. It is also pref 0 of some index into y minus pref 1 of some index into x. And RHS is also similar. Pref 0 into some index into y minus x into uh, pref 1 into x into some pref 1 index. Okay. So what I want you guys to do is just understand my thoughts and emotions. I am saying that whenever I am at an index j, can I find out all the subarrays which are ending at a proper I? Say there was I1, okay? Say there is I2, okay? Say there is I3, okay? Say there is I4, okay? Say there is I5, okay? Now you want to know which will be the subarrays from I to J format like this, I to J, which will be valid. So first you calculate the RHS, the RHS value at the jth index. What is the RHS value? RHS value is x into pref1j minus, let me check. RHS value is pref0j into y minus x into pref1j. So this is the RHS value. So you calculate the RHS value here. Okay. Let's say the RHS is phi. Now this should be equal to the LHS. What is LHS? For each index you can calculate the LHS. LHS is what? Pref 0 I minus 1 into y minus pref 1 I minus 1 into x. So basically say you calculate the LHS for this. Okay, let's call LHS as L1. L1 is say 5 here. Say the L2 is say 1 year. Say L3 is say L3 is say 3 here. Say L4 is 0 here, and say L5 is 5 here. So guys, with which pairs will J match up? With which index I will J bond and make a valid subarray? Only if it is matching the RHS. RHS is phi. So I phi to J is valid. I phi to J is valid. I phi I phi to J is valid. Okay, this is valid. Why? Why this is valid? Because in this case the RHS you calculated is equal to the LHS. RHS was also phi, LHS is also phi. Is I4 to J valid subarray? No. L4 is 0 and RHS is phi. So phi is not equal to 0. L3 is 3, RHS is phi. So 3 is not equal to phi. I2, the LHS is 1, RHS is phi. Not valid. I1, L1 is phi. Okay, same. When both the numbers are same, when LHS phi is equal to RHS phi, it means it is valid. So I phi to J was valid. Now I1 to J is also valid. Okay, now I1 to J is also valid. So guys, the question will be so easy. What you have to do at each particular, the algorithm is very easy. You travel the array from start to end. You travel the array from start to end. At each particular index, you calculate the LHS. You calculate the LHS and store it in a hash map. Calculate the LHS and store it in a hash map. Then you can imagine that you reach some index J. You calculate the RHS at this index, and you can easily check in the hash map how many LHS are matching your RHS. As simple as it could get. So just keep on calculating the LHS and RHS, and the best thing is that the LHS RHS are both the same. So what will be the most important part of the pseudocode? This part will be, guys, a very important. Okay. Let's take a little bit piece of code. No need. Okay. Let's say, guys, we had an array B. Okay. Its size was say n plus 1. Okay. We also calculated our prefix 1 array. Size I'm taking n plus 1 because I like 1 based indexing. And we also have prefix 0 array. We have calculated all of these. No need to worry. Okay. Now our algorithm will be very simple. Let's say we declare a hash map. The name of the hash map, let it be say k. Okay, hash map k. Okay, the left hash map k. the left value is integer and the right value will also be integer. Left will be storing the number, right will be storing the frequency. So the pair will be number comma frequency. Okay, so all I need to do, guys, is say I start iterating from j equal to 1 while j less than equal to n. Now all you need to do is you need to calculate the LHS. You just calculate the LHS. What will be the LHS? LHS will be, what will be the LHS? LHS will be this value, right? Prefix O I minus 1. Okay, it will be this value, right? So easy. So easy. So you just come at each value, calculate the LHS. Come at each value and calculate the LHS. So simple and so nice. You just come at LHS and you calculate. So yeah, you calculate the LHS, right? Such a nice existence. You calculate the LHS. Now I want all of you to put this LHS in your hash map. Insert the LHS in your hash map. Just insert the LHS in your hash map. So K of K is my hash map, right? So K of LHS is equal to, I will increment the frequency now, I'm inserting it. So K of LHS is equal to K of LHS plus 1. That's it. That's it. That's all we had to do. Okay. So suppose I am starting at index I equal to 1. Okay. Then I come at index I equal to 2. Then I come at index I equal to 3. Then later on in life I reach some index j. I calculate the L1, which I'm saying as LHS. Then I'm calculating the L2. Then I'm calculating the L3. As soon as I'm calculating them, I'm putting in my hash map. So hash map will look like this. Okay, now hash map will look like this. L1 is coming for one time, so left value will be the number, right will be the frequency. Then L2 is coming for one time. Then L3 is coming. Some values can come multiple times also. So just like that, guys, just imagine that your I is 1. Okay, I is 1. Then your I is 2. And then your I is 3. So let's say the LHS at this point is 5. LHS at this point is 2. LHS at this point is 3. LHS at I equal to 4 is, what is the LHS? L4. It is equal to 40. And say the LHS at I equal to 5 is L5 is equal to 5. Okay, guys, L5 is equal to 5. So how will your hash map look when you are till this index in the for loop? In this for loop, where were we? Yeah, when you're at index 1, you calculate this LHS, right? And you push this LHS in your map. You increment the frequency by 1. So when you are at 5 na, your hash map will look like this. It will look like this box where it will say that 5 is coming for one time. Okay, when you come at this index na, the hash map will be saying that 2 is also coming for one time, so even that will be situated. So now the hash map will look like this: 5 coming for one time, 2 also coming for one time. Okay, similarly, when you come to the third index, the hash map will be saying that 3 is also coming for one time. So it will look like this: 5 comes for one time, 2 comes for one time, and 3 comes for one time. Okay, so now when you come here 40, the hash map will now look like this. 5 comes for one time, 2 comes for one time, 3 come for one time, and 40 comes for one time. Now when your hash map comes here, it says 5 is coming again. 5 is coming again. So it will do k of 5 equal to k of 5 plus 1. K of 5 was already 1. So 1 plus 1, 2. So now this will be incremented. First it was saying that 5 is coming for one time. Now it is coming for two times. So final hash map will look like this. 5 coming for two times. 2 coming for one time. 3 coming for one time. And 40 coming for one time. Now let's say after this fifth index you reach the index number 6. Okay now. You reach the index number 6, let's call it as j. Okay, you reach the index number 6. Now you don't want to calculate the LHS here. You will calculate that later on. Okay, this is not looking good. So let's say you come at index 6. You call it as j. Okay. Now what you can do, you can calculate the RHS at this index. You can just calculate the RHS at this index. Okay now. You can just calculate the RHS at this index. Okay. You can just calculate the RHS at this index. And it is very important to calculate the RHS. So once you are done calculating the RHS at this index, say you calculate the RHS at this index and the RHS comes as 5. RHS comes as 5. RHS comes as 5. So how many index I are there which will make a valid bond with J? Say you come at index j equal to 6, you calculate the RHS comes as 5. So which index I will make a valid subarray with index j? So the answer will be RHS should be equal to RHS, LHS. LHS should be equal to RHS. RHS is 5. So now in just O of one time you can check how many times 5 has come. So how many times 5 has come? 5 has come two times. So you can say there are two indices. There are two indices such that they are ending at index j. There are two such indices. Okay now. There are two such indices because 5 is coming two times. Which are those two indices? I equal to 1 and I equal to 5. I equal to 1 and I equal to 1, 1 to j and 5 to j. So this way I am saying just keep on storing the LHS value, and now you can check at this point you can check if you can check the number of valid subarrays ending at index j. Okay, you can check the number of valid subarrays ending at index j. Which will be those subarrays? Let's think about it in detail. Okay, so they should be such that RHS equal to LHS. So what will be the RHS? The RHS is always fixed, right? Should be writing J minus 1 because we are using J index. No? Okay, what will be the RHS? RHS, this is the RHS, guys. Pref 0 J into Y minus X into Pref 1 J. Now all you need to know how many times this RHS has come before. It means how many times this RHS is equal to LHS. So answer is equal to answer plus how many times this RHS has come. So this will be nothing but K of RHS. K of RHS. Okay now. K of RHS tells you how many times RHS has come in the map, come in the hash map. So guys, this is very easy. You are already storing the values in the K hash map. Now you just want to know, say your RHS is 5. So you know na, at index j equal to 6, we calculated that the RHS is 5. So you want to know how many index further from 1 to j minus 1, how many I are there such that their LHS is 5, because you want to make LHS equal to RHS, and we know that there are two times this case happened. Okay, at this place and at this place. So this was already stored in the map. So K of phi, this is the K map. Okay, its name is K. K of phi will be equal to 2. So there are two subarrays. So K of phi equal to 2, it means there are two subarrays valid which are ending at index j. Okay guys, that's it. And once it is done, you can declare answer equal to 0, and then you can like print the answer finally. Okay. Now there is one more trick. Why did I make the I and j separate in the equation? I made I and j separate in the equation because in the subarray problems, always remember, they are always asking you to do some find the number of subarrays with such property or this or that related to subarrays. So in subarray, it is very important that you analyze the subarray first before solving the question. What is happening in that subarray? You have to analyze. So when you do the analysis, you come to know that I is here, you come to know j is here. Now if you're experienced person, you will be knowing that you will have to use some hash map. There will be some I property which will be equal to some j property. So it is common sense that the LHS should be having all the I terms and the RHS should be having all the j terms, so that you can make it equal and you can check it in the hash map and count and do the counting. Okay now. So basically, why are we trying to make it? Why did I make the I and j in the formula different? See, earlier I and j were mixed up. J and I minus one in the LHS and j and I minus one in the RHS. If this was the equation, you would never be able to find your answer. Why? Because at a particular index, how will you know? How can you calculate the RHS? The RHS would be what? Pref one j minus pref 1 I minus 1. You don't even know what the I is. How can you calculate? So you want all the j index on the right so you can calculate the RHS properly. क्योंकि j की तो सारी वैल्यू तुमको पता है ना jth इंडेक्स पर. I पता ही नहीं कौन किधर क्या है. So that's why the I at one place, the j at other place. Okay guys. Now there is one more thing I did not do. Like we can calculate the prefix 1 and prefix j. So that is also very simple. If you want to calculate, what you could do is you can just run a loop I equal to 1 while I less than equal to n, I equal I plus plus. What you can do is if guys, if the current element is 1, then pref 1 I is nothing but number of ones till index I is nothing but number of ones till index I minus 1 plus 1, because now one more 1 has come. And if that's not the case, if that's not the case, if the number is 0, then the number of zeros till index I is nothing but the number of zeros till index I minus 1 plus 1. Okay. And pref 1 I will remain the same. It will not increment because the current number is pref 1 I minus 1. Current number is 0 na, so the number of 1s till index I will be equal to the number of 1s till index I minus 1, because the current number b of I is 0 in the else condition. And similarly, if the current number is 1, then the number of ones till ith index is nothing but the number of ones till I minus 1. And I minus 1 you have already calculated, because the loop is going from 1 to n plus 1. Similarly, if I go below pref 0 of I, in this case, the current number is 1. So it means the number of zeros which you have till index I is same as the number of zeros you had till index I minus 1. Pref 0 of I minus 1. All the C++, Java, Python codes, all the pseudo codes, everything will be uploaded for your help. Okay, no need to worry about anything in this world. I'm always with you. I will make sure that you get the best job, the best success in your life, with job, life, health, mindset, full stack development. I will try to fix everything for you. always make sure to come in the Kumar case mentoring and training program. It is very different from others. Okay, I try to give the personal guidance, personal training, personal mentoring. That's why the students are becoming so successful. Before each interview and OA, I personally guide them. That's why such results come. Like if you go guys and check today, back to back, two of my students cracked 20 LPS that Skiller offer. Now why did it happen? Because for both of them I was in personal touch. Okay, not like other influencers. I don't just keep on posting my pics. I bring real change. What is real change? Real change means bringing real change in other people's life. So if you guys go below and you guys check, you'll come to know that we have so many student selections. Students are getting selected again and again, again and again. Arav, Aman. Because see, he did the OA practice from my question set. That's why he cracked the Zscaler OA. Even though he was a full beginner, even then in 1 to 2 months he practiced and cleared it. Then before each round of interview, me and sometimes, like in some cases me, and in some cases Didi, and in some cases we both help the person before each interview round that what can be asked, prepare this and that. That's why so many students keep on getting selected. See, he selected, got 20 LP offer. How nice and loving and wholesome is this? If you study nicely, work hard, God will always give you the best results. For now, let's close this session. So where did it go?